Assalamualaikum students. I hope everything is going fine. I think we should have a video call or something like that so that we have a proper class. So I don't know how to do the video call, so I'm just recording this video. I'm going to explain the topic in this video. You can watch the video and then try to text me during the school hours, because yesterday was really crazy. So let's start the new topic today, converting rectangular to polar equations. Okay, so today's date is 3rd 17 2020. Okay, so to convert a rectangular equation to a polar equation, as we know, x equals r cos theta and y equals r sin theta, there will be three kinds of different methods we will be using. The first one would be when we have in terms of x equals -3, y equals -3. This is the rectangular form. We have to change it to polar form, meaning in r and theta. Okay, because we have in terms of x and y, this means it is in terms of rectangular form. Now the other equation is with y equals x squared, when we have squared term, and then when both are squared. So let's get started. The first step would be, as we know that x is equals to r of cosine theta, then we can just replace x with r cosine theta. We just want to change the form to the polar form. So I'm going to replace this x with r cosine theta. I get r cos theta equals -3. Now because I want my equations in polar form, in polar forms we know our equations. You should have three reference sheets with you, as we know our equations were in this form: r equals a cos theta, or r equals a sin theta, a plus minus b cos. These were our equations for polar curves, remember? So we are going to make it in terms of r or theta or something with r equals r square equals 2. So I'm going to make it to, I'm going to isolate this r. I will have r equals -3 over cosine theta. What I did, I divided both sides by cosine theta. Now I know that I can write it as r equals -3 times 1 over cos theta. 1 over cos theta can be written as secant theta, right? So my equation is -3 secant theta. This is my final polar equation. And if you go back, you would know that how to graph r equals -3 secant theta. It's a straight line, a vertical line. Okay, go back to 7.1, review if you don't remember. Now the next question, the same thing, y equals, I'm gonna replace y and x, or one more thing we know is tangent theta. I want you to write this here: tangent theta equals y over x. Okay, so there are two ways of doing this question. I'm going to do both ways. What we can do is either we divide both sides by x so that I get y over x, and I can replace y over x with tangent theta. And why do I want tangent theta? Because I want to change it in terms of polar form. And to change in terms of polar form, I need either theta or r. Because I have y and x both, I can change it to theta using this one. So what I can do is I divide both sides by x. So when I divide both sides by x, I get y over x equals x square root 3 over 3 dividing by x. Now I get y over x equals, x and x cancels out, I get x square root 3 over 3. Now I can replace this y over x with tangent theta, and I get tan theta equals square root 3 over 3. And because I want in terms of theta, my equations could be in terms of either theta or r. So theta would be equal to tangent inverse square root 3 over 3. Using my unit circle, when is tangent inverse equal to square root 3 over 3, I would see here it's 1 over 3, 1 over 10, this is tangent value, 1 over square root 3, which is equal to square root 3 over 3. So I get pi over 6. So theta equals pi over 6 will be my final equation. The other way of doing this is you replace y with r sine theta, x with r cosine theta. So let's do it the way we did this question 1. So if I replace this, I get r sine theta equals, I'm replacing x with r cosine theta times square root 3 over 3. Now what I can do is I can divide both sides by r cosine theta, so I get r sine theta over r cosine theta. If I divide here r cosine theta, this and r cosine theta cancels out, so I get square root 3 over 3. R and r cancels off, I get tangent theta equals square root 3 over 3. The same step after we did this, as theta equals tangent inverse of square root 3 over 3. And we are going to look for in the unit circle, when is tangent square root 3 over 3, at what angle? It is pi over 6. Now let's go back to the next question. When we have squared, so the same step, we are going to replace y and x. I get replacing y with r sine theta equals x with r cosine theta. Because it's whole squared, I'm gonna square it, so I get r sine theta equals to r squared cos squared theta. Right, now what I can do is divide both sides by r. Okay, I want to simplify my equation, so I get sine theta equals to, cancels out one of the r, I get r cos squared theta. I can see I have an r here, so if I divide both sides by cosine square theta, I know that I can change sine over cosine to tangent, and I would have an equation. So in terms of tangent, right? So if I divide both sides by cosine square, I get sine theta over cos squared theta equals r. Now I know this means 2 cos times cos, so I can write it as r equals sine theta over cos theta times cos theta, is it? Now sine over cos becomes tangent, and this is 1 over cos, right? So I can write it as r equals sine theta over cos theta becomes tangent theta times 1 over cos is secant theta, right? So this is my final equation in terms of tangent theta and secant theta. The same we are going to do in question number 4. you replace x and you replace y with r sine theta and r cos theta. Then try to simplify in such a way that the way we did that, divide cosine sine over cos and change into tangent or cotangent. I'm just gonna show you the final answer is equals to r 5 times cotangent theta times cosecant theta. Now you can show the work. The last example I'm gonna do is this one. X squared plus y squared equals 16. You can compare it with the equation of circle. If you guys are preparing for SAT, you know that this is the equation of a circle. X squared plus y squared equals 6 r radius squared, meaning the radius would be equal to 4. Now straight away, if I want to change it, this rectangular form to the polar form, I know that radius is equals to 4, and in polar form I can straight away write that this is going to be a circle with radius 4. This is going to be my equation. I know my answer from now, but let's do algebraically. I'm going to replace x with r cos theta and y with r sine theta. So it would be r cos theta whole squared plus r sine theta whole squared equals 16. Okay, so now this squared applies to both. I get r squared cos squared theta plus r squared sine squared theta equals 16. We have to implement all our Pythagorean identities, our reciprocal identities. So keep this reference sheet next to you. Okay, so let's get started. Now I can factor out r squared, so I get r squared, and I have cos squared theta plus sine squared theta, which is equals to 16. I know my Pythagorean identity. Sine squared plus cos squared theta equals to 1, so I can straight away replace this with 1 and I get r squared times 1, which is r squared, equals to 16, and r is equal to either positive or negative 4. But as we know that r equals to negative 4, meaning radius of negative 4, its radius is just a distance, so we're going to take r equals 4 as our final equation. Okay, the same we are going to do here. Make sure you keep the reference sheet next to you wherever you get something with cosine squared. You will see cosine squared theta minus sine squared theta in this question. You have to replace it with cos 2 theta, okay, and you will get your final answer as r squared equals to secant 2 theta. Okay, now let's move on to the next page. We have question 7 and question 8 here. Okay, so for question 7, I can see here that my radius x squared plus y squared, this is my equation of a circle, and if you are practicing for SAT, I know my center is at -1 and 0, and this is going to be the radius squared, which is not in the squared form. This is in the squared form, sorry. So let's get started, but our circle is not on the origin. It's at -1 and 0. So let's get started. Bismillah. So here, first of all, I'm gonna open this up. So I get a plus b whole squared. I know it opens by a squared plus 2ab plus b squared. Okay, so this will be x squared plus 2x plus 1 plus y squared equals 1. Now you can replace x and y at the first step, but it's easier to simplify this first and then replace x and y. Now I can cancel these two ones, because if I subtract 1 on both sides, I get 0, 0. I get x squared plus 2x plus y squared equals to 0. Now here at this point, I'm going to replace x and y. So I will need enough space. R cos theta squared plus 2 times r cos theta plus r sine theta whole squared equals to 0. If I open it up and expand it, I get r squared cos squared theta plus 2r cos theta plus r squared, because this is raised to the whole thing, r squared sine squared theta equals to 0. Okay, now what I can do is, I know that these two terms of r squared, I'm gonna combine I'm gonna combine them and I'm gonna factor out r squared, and then I can see cos squared plus sine squared will be equal to 1. So let's move this to this side and this to the other side. So it will be r squared cos squared theta plus r squared sine squared theta equals, I'm going to move this to the other side, minus 2r cos theta. Don't forget we have to find the equation, okay? So I'm factoring out r squared. If I factor out r squared, I get cos squared theta plus sine squared theta equals to negative 2r cos theta. This becomes 1. So I know I get r squared equals to negative 2r cos theta. If I divide both sides by r, what do I get? Divide both sides by r, I get r equals negative 2 cos theta. Your final answer. We good? So this is my final answer. I'm going to tell you the final answer for question number 8. Try doing question. R equals 4 cos theta minus 2 sine theta. Okay, so this is your classwork. Due page number of homework will be homework 4, page 25, 26 to question number 12. Show me before the I would say before 4 o'clock today in the afternoon, inshallah. And that's it. We'll do this tomorrow, inshallah.